In this video lecture, we will understand what is estimation. So, from the word estimation itself, it is evident that estimation is a process of estimating something. So, what is this something? I will tell you. Estimation is a process of estimating the value of population parameter, and parameters are nothing but the characteristics of a population, that is numerical descriptive measures. That means the characteristic of population is described by some numerical values like mean, variance and standard deviation. Now let us take an example. Suppose if we have a population and we take a sample from that population and we calculate the sample mean, which comes out to be a numerical value. Then the x bar, which is sample mean, is called the estimator of population mean mu, or we can say mu hat. Okay. Now we give the definition of estimator as: an estimator is a rule often expressed as a formula that tells how to calculate the value of estimate based on measurements contained in the sample. So basically we applied the formula of sample mean and we obtained the value of estimator. There are two types of estimation, that is point estimation and interval estimation. A single estimate is obtained in point estimation, and in interval estimation an interval is obtained consisting of lower and upper bound in which the value of estimate lies. We have already taken an example of point estimator. Now we will continue that. Suppose that a manufacturing factory wants to know the average life of light bulb manufactured, and now we wish to estimate the average life of light bulb. Then we take a sample of light bulb and use formula of sample mean to estimate the average life of light bulb, and numerical value is obtained. Then the sample mean x bar is nothing but estimator of what? Population mean mu. Okay, and the value obtained is called estimate, denoted by mu hat. And the average life of light bulb estimated is called estimate. The thing we are estimating, which is population mean, we are estimating the population mean, so it is called estimate. And the process of estimating the average life of light bulb using estimator sample mean is called estimation. Now we come to the bias, mean square error and point estimators. Suppose that a man fires a single shot at a target and that shot pierces the bull's eye. Can you conclude that he is an excellent shooter? Okay. Some might say yes, or some, like 1% say no. Here's the reason why. We can say that he had an excellent shot, but we can't say that he is an excellent shooter because it can happen by chance. Okay. But if he shots 100 times in succession at the bull's eye, we might acquire sufficient confidence that he is an excellent shooter. Okay. The point is that we can't evaluate the goodness of a point estimation procedure on the basis of a single estimate. Rather, we must observe the result when the estimation procedure is used many times. Because the estimates are numbers, we evaluate the goodness of point estimator by constructing a frequency distribution of the values of estimates obtained in repeated sampling. And note how closely this distribution clusters about a target parameter. We can say that the estimates of target parameter should be clustered closely around the target parameter, and the distance between the estimates and target parameter should be as minimum as possible. Now look in figure A. The distance between the estimates and the target parameter is larger. Theta 1 hat not a good estimator of target parameter. Now see in figure B, the estimates are clustered closely around the target parameter theta. So we say that theta 2 hat is it a good estimator of theta. And by this we conclude that the expectation of estimate theta hat should be equal to parameter of the population. And we give the definition of biasness as let theta hat to be a point estimator of parameter theta. Then theta hat is unbiased estimator if expectation of theta hat is equals to target parameter theta. If expectation of theta hat is not equal to theta, then theta hat is said to be biased. And similarly, definition 3 is given as the bias of a point estimator theta hat is given by bias of theta hat equals to expectation of theta hat minus theta. And lastly, definition 4, the mean square error of a point estimator theta hat is MSE theta hat equals to expectation of square of theta hat minus theta. To derive this, we take theta minus theta hat ka square and then we open the formula, take expectation on both sides and then we add and subtract the expectation of theta hat ka square. Then we get variance of theta hat plus bias of theta hat ka square.